So yeah, I'm Ray I'm a PhD. This is my final year at the University of Auckland. So I titled my presentation today STEAM-X model. Well, we are familiar with what is STEM or STEAM. Um, X here is representing experiential. So I've been doing this PhD for like almost 6 years now, though I am originally from the Philippines. So basically, while I am analyzing my data, I come up with this kind of concept or idea, and I presented this to the university, to my faculty. Fortunately, it won a prize in the university for this kind of idea. My field is in science education. I taught science in the Philippines. I also taught in the United States, specifically in South Carolina. I also taught in the UK. So it's just around 15 years now before I went to New Zealand. So basically, this model is as you can see there, linking science, ethics, human experience, and AI. Timing that AI is very significant in the past years. So,
Mm-hmm.
okay, I said it's a very good timing because the education system, the current education system, the traditional system of the world in the field of education is, the traditional things that we know, the lecture-based worksheets. If you teach middle school, that's very common. The traditional going to the lab and, do some experimentations, following the step-by-step procedure there and so on. But during my research is actually focused on anthroposophical science education. Um, Anthroposophy is a German philosophy before World War One. I'm pretty sure you're familiar with Waldorf or Steiner school. This philosophy says that before the expansion of space-time, the Big Bang, there is this they call powerful energy-like thing. Sometimes they call it the uncaused cause, non-atomic in nature that caused the rise or the collapse of our physical atomistic reality. So that's anthroposophy. Science education, science, the way of knowing, quite commonly also known as a body of knowledge. It's a way of knowing or just to understand our truth, our reality. We rely on measurement and observation. That's the characteristic of science. Education, as we know, is the teaching and learning. And I'm also a science teacher. I do high school. So yeah, moving on. I got 1 hour, but I'll try my best to finish this in like 30 minutes or 45. So the model is divided into 6 phases, and this model is still developing in my faculty. So phase one, well, instead of me presenting what are the 6 phases, I think I said it is necessary for us to experience each phase itself. Um, it's more the retention is stronger if we experience the concept rather than being taught or being spoon-fed. So that's the idea there. So okay, since we are doing online, I feel this is more dynamic if in person, but since this is via Zoom, we'll just do online stuff instead. So because we cannot go out and go to nature and do physical activity, we'll just probably analyze a short video. So this model begins with collecting data instead of presenting quite commonly. When I was still in the US, I start with, okay, guys, our objective for today is this, blah, blah, blah. And sometimes I say, okay, here's the worksheet, answer this document, and then we can go to the lab later. So, but here in this kind of model, we begin with analyzing or collecting data. So I'm going to show a short video. You don't need to explain. What we're going to do is we'll just observe and take down notes, what we observe exhaustively using our senses. I understand we got some, strong background in science, but let's pretend that I am your middle school teacher. You are my middle school students. So as if you don't know anything. So, okay, I'm going to play this now. Wait, where I'm going to go. Okay. Okay. So here, I got this video from Facebook. So, okay, let's try to observe this one. This is phase 1.
This is gonna freeze your house.
Oh, by the way, do you hear the sound? I think so.
Yeah.
Okay.
Put
Hear it
ice on
loud
the
and clear.
fan and you'll never use air conditioning again. That's right, everyone. Today I'm gonna show you a simple way to make a powerful homemade AC using only 2 plastic bottles, 2 liters each, and your fan. A great way to cool off without spending much on hot days. So you're gonna need 2 plastic bottles of 2 liters each. Cut the bottom part and then make several holes, leaving space near the mouth of the bottle. And these holes are gonna help the cold air to spread, cooling the environment when the fan blows. And if you're really suffering from the unbearable heat, listen carefully, cause I'm sure this is gonna help you a lot, because this made a huge difference here at home. And this is how the bottles should look. Now take your fan and carefully remove the front guard. Then also remove the blades. And let's position the bottles at the back of the fan. For this, let's use plastic ties. After securing them well, just give it a little trim. Next, go ahead and reassemble your fan. And our tip is almost ready. All you need to do now is fill the bottles with ice. Add ice cubes up to the height of the holes. That's why it's important to leave enough room. Now all you gotta do is turn on the fan, cool down and enjoy. The fan will pull the air through the ice, making the wind refreshing and more pleasant to you. Now you don't need an expensive AC or even ceiling fans. This tip is definitely gonna help you. As soon as you turn on the fan, you'll feel the ice-cold, refreshing wind coming out of it. This is a quick, easy, and also cheap way to cool off on hot days. And best of all, it doesn't change anything on your energy bill. And when the ice melts, just open the lid and remove the water without a mess. And whenever you want to use it, just add some more ice. Another great tip is to make ice with cotton. This way it's gonna last much longer. So that's it. I really hope you guys liked it. Don't forget to try this at home. You're gonna love the results.
Okay. Right. So if we are meeting in person, wait, what's going on there? There you go. If we are meeting in person, then for sure, the plan here is we go outside and probably try this hands-on, but because we are doing it online, I cannot see them. Wait, hang on. I'm not really good with this Zoom. But anyway, so let's do this way. So we tried to analyze the video. Let's pretending we are students here. Perhaps we can collect some data based from our observation. So Kelly, maybe pretending you are a middle school student, then what could be your observation? Well, the observation, if we jot down notes on a science notebook, there could be, it's a long list, but for the sake of time, maybe you can share what you observed from, you know, um, from that video. Yeah.
Well, I'm guessing that I would observe that the air from the fan is indeed quite cool and
Mm.
cooling if we make this ourselves outside.
Yeah, yeah. Pretty sure if we do the activity, especially if it is in person, then this will be very cool because it's really experiential. And by the way, I forget that in phase one, I need to mention the objective. At least the students got the idea of what they're doing. So in this case, we are going to define convection based on our experience rather than me telling the prepackaged definition coming from Google or from textbook. Perhaps if I'm one of the students, maybe I can say that, okay, there could be some changes in the temp. Well, it becomes cooler because here in the Philippines, it's hot here. If I try to do that in my house, then that will become cooler or I feel more comfortable. Yeah, cash probably as if you are middle school, not a PhD. What's your observation, perhaps? Yeah.
Yeah, similar to what Kelly was thinking. I was thinking of like, yeah, if there's the ice, the air which is on the ice would become colder. And because there's so many holes, it'll be able to draw out that cold air and push it on you. So I was thinking that without, like they said on the video, without spending any extra
Mm,
money or getting colder air. And I was originally thinking about what happens when the ice melts and would the water just fall on the fan and be a hazard. But they had that, okay, you can open it and drip it off every now and then. So that's what I
mm.
had.
Yeah, so all these observations are, well, real observations, empirical observation. Uh, like, what about you? Are you a PhD? Sorry, are you a PhD or a faculty in in China?
Uh, well, I'm a doctoral student in Central China Normal University,
Okay.
and
Yeah.
my major is uh, chemistry instruction.
Oh, wow. Yeah. The content,
Uh,
the content of chemistry plus how to teach chemistry content. Yeah, which is
yeah, it's
quite
highly
difficult.
related to science education. Mm,
Yeah.
and
Yeah.
my English is not so good.
Oh
Um,
no, no, it's all right. In fact, we fully
that's
understand. Yeah, yeah. So you are very clear. So we are fine with that. So okay, so like as if you are a middle school or elementary student, so based from that video, analyzing that short video, what could be your um what have you observed?
Uh, yeah, this is a kind of plan I have never thought of. Using two bottles with ice, and we can find that the bottom of the bottle are upside, and it seems that the wind cannot directly go through this ice. But we know uh, cold air will uh, automatically go down. So I think the cold air can go from the
Mm,
high place and go through the and
yeah,
we can get cold wind.
yeah,
Mm.
exactly. So if we notice all these observations are just pieces of data, it's like pieces of puzzle. Though I put the objective there, how do we define convection? But if I'm the student, like, okay, I got all this information and pieces of data, but how exactly I'm going to construct definition of convection based from this data. So that's the problem there. Otherwise, I'll just go to the textbook and, hey, what's the definition here, or dictionary? That's the traditional way, or quite common in pedagogy. So now, phase one is basically natural encounter, experiencing the reality, which is the tangible reality based on measurement, based on observation. So as if we got the data here. Well, for the sake of time, I put some data here. Like based from what you said as well, air moves from the fan outward. How did I say that? Because, well, I got a prior knowledge, and basically, actually, I did that before, long time ago, like the electric fan, and then behind it, there's some ice cubes like that, because again, it's very hot in my country. So experientially, and my background knowledge says that air moves from the fan outward, cooling strongest if you're very close to the fan. Otherwise, it's not cool if you're quite far. Cooling decreases with distance, and then cooling spreads over time. The smoke or the vapor moves with the airflow. Perhaps if the fan is rotating, that I can see the curtain moving back and forth like that, or I can see the vapor if ever there is a vapor. No cooling when the air is still. Cooler air stays lower while warmer air rises up. Maybe I can, not maybe, but we can actually feel that there is this shift of movement of air, like we feel cooler yet warmer. So those are pieces of data, but we do not know yet from here, we do not know yet what is convection really, or what does it really mean. So what we're going to do is we're going to move to phase two, which is the independent structuring. So if we are students, then we need to organize these data. So we need to seek patterns or recurring patterns like movement, cooling strongest near the fan. But if you're far, it's not. We sense that cooling is spreading over time. So that means there is this motion going on. And then motion is associated with flow and so on. Air stays lower while warmer air rises. So using our 5 senses and based from all this information we gathered from our observation, we can probably construct and refine our thinking, our conceptual modeling or constructing of what exactly a convection is. Well, chances many students will give quite off information because, you know, it's like inductive. We don't know, but we start from the data because we start from experience. So, but pretending we got all this data now, we need to organize all this. So in phase two, AI will come in because we got the data, we tried to analyze the patterns, recurring patterns, and we got some concepts here of, we also developed some concepts, initial concepts of, oh, okay, the cool air is going down, warm air is going up. So technically there's some sort of flowing movement going on. But that kind of concept, initial concept is still poor or crude, in other words. So we need help from AI to refine our thinking. So after synthesizing our thoughts based on the observed data, we can seek help from AI, whatever kind of AI, I don't know, ChatGPT, Copilot, etc., to augment or refine our thinking. this is also quite helpful for non-native speakers like me, which is not really good in English, but though I speak English, but you know, writing, especially in the PhD life right now, writing, I think, is one of the difficult journeys that I'm experiencing. So okay, so based on the data we observed, we gathered, AI could help us construct certain information or, you know, scientific concept that will lead us to the idea of convection. So that's independent structuring. So during the analysis, we got all this information that air moves from the fan because we can actually feel it based from what we observe. There's this vapor happening or moving. And then, yeah, as I mentioned, the temperature effect is strongest when the air is moving the most. What else here? No cooling when the air is still. Air forms a circular pattern because based from what we observe, there is this circular thing going on, or motion at least. Though some data are quite limited if we only rely on a video, but for the sake of this, you know, webinar, that's the best I think that we can do. But again, as I mentioned, this is very dynamic and engaging if we are doing in-person, hands-on. So in phase 2, they will construct their idea of convection with the help of AI, because the idea here is the concept or the construction of concept must not rely first or must not coming first from AI, but AI will only be a tool to construct or refine the you know, the data that we gathered. To make learning more authentic, the construction must really begin from the students rather than from AI. AI is a tool to augment or refine our thinking, but it should not come from AI. That's the premise. So in phase 2, perhaps we can come up with an idea that energy, heat in this case, is moving. There is this flow in the room, and this flow carries warm and cool regions from one place to another, forming the circulation. So yeah, through AI and from the data we got, we can come up with an idea that energy, which is heat, is transferred or moving. When moving air carries warm and cool regions from one place to another, it forms a circulation. So from that point, we can have a constructed definition of what is convection, which is simply the flow of heat energy, or simply energy in fluid, which is either water or air. And that construction of concept was defined by students or by us based from the data we got, from the experience we got, though the data and the experience might be a little bit crude and requires refinement from AI, but at least the data came from human experience. So we just need refinement. That is why after phase 2, we will proceed to phase 3, which is knowledge verification. This time, a short lecture will come in, the traditional lecture that we know. So the teacher will come in. Well, from the very start, teacher is facilitating everything. But in phase 3, this is the time that lecture will start. The purpose of this is for the teacher to resolve misconceptions. Though there is AI, but it requires a human being to further refine the idea. So if I'm the teacher, I'm going to start a short lecture on what is convection. At least despite of having me projecting the PowerPoint slides about convection on the screen, they already got the idea of what exactly convection is based on the data they got and with the help of AI, rather than me traditionally, the traditional way of, spoon feeding the information of what is convection. So, so for example, here, if you see my screen, so probably I could present this for like 15 or 20 minutes. The purpose of me lecturing about convection is to refine their thinking, despite of they already got this concept based from the experience earlier. Air cools, becomes more dense and sinks. Air warms and becomes less dense and rises, and so on. So this is phase 3, the lecture part. AI still can be used in phase 3 to further visualize or summarize, even to further analyze existing evidence or to explore further concept or simulation. Phase 2 is I call it negotiated opposition, because in this phase, students will go back to their work after data collection. Then next is analyzing with the help of AI. Then the third phase is knowledge clarification, lecture-based. The fourth is the students will go back to their work and refine whatever they got there, their concept of convection. By the way, this kind of model, though this idea surfaced from science education, from my data in the field of science education, but this model can be used across the board. My initial plan is to present the use of AI as a topic today, rather than convection, or probably the idea of divorce or photosynthesis, but I just decided to do convection because I feel it's easier considering the time. So this model could be used in any aspect. It could be in your personal life, it could be in your love life, it could be in anything. It's just the model that I present. Yeah, it's like similar to scientific method. It doesn't mean that scientific method can only be used in science, but it can be used in business or in anything as well. So anyway, so phase 4, the negotiated opposition. This is autonomous thinking. Students return and revise ideas. They do iteration and so on and so forth to fully refine the idea of convection. Phase 5 is ethical framing or ethical reflection. So this is where they are going to construct some kind of ethical guidelines, but related to the concept of convection. In this phase, the teacher, for example, me, could also invite panelists or external moderators to triangulate the idea. What particular ethical framing or guidance, perhaps? Since the data we gathered is leading to the idea of convection, what could be some issues that are very trending in the past years or in the recent years that are related to convection? So it will be the teacher to decide on what particular issue they are going to argue or debate on, but still the decision making on what particular guideline they are going to construct will be based on the evidence or on the idea of convection. So for example, if they're going to decide on, let's construct ethical framing about, what did I put here? Okay, I can come up with something about climate change, for example, because climate change is relevant to convection. So I got the idea now of what convection means. So students were going to sit down with some moderators, perhaps, and panelists, and to discuss on some guidelines related to climate change or global warming, perhaps. So my idea earlier of what is convection helps me to construct a better ethical framing on how we could respond to global warming or climate change. That could be some of the examples. In this particular phase, students will act as policymaker. But the way they do policy, even though these policies are very simple within their context, is also based on evidence rather than, because, for example, in the Philippines, we got a lot of issues on policymaking. And I think this is across the world as well, that policies are sometimes not based on evidence or not really based on data. So that becomes problematic. So the idea of phase one here is to construct ethical guidelines based on what is the data is saying or are saying. So the idea of convection probably could help me to construct at least simple guidelines to combat global warming or climate change in my own context, not essentially to change the world or my country, but at least in my context. This ethical framing is coming from the students themselves rather than from certain agency or government itself. So there is this sense of ownership there, and this will be an opportunity as well for students to develop their sound judgment, but based on data. The last phase is the knowledge documentation. In this case, this is where students were going to present their work from the very beginning, what they did in phase one, nature encounter, because for every phase, they need to document stuff. They need to jot down everything they do. They need to make sure everything is documented. And, you know, this is also assessed. The teacher will going to assess their work. So each phase must have a tangible documentations going on. So like what particular documentations, it will be the teacher to decide and, you know, to convene and talk about how they're going to do the rubric or how they're going to assess. Because at the moment, what I'm presenting is the model or the flow. So in terms of knowledge documentation, for example, earlier we did convection. So probably if I'm the student, I could do like portfolio-based or scrapbook, or we are going to present a school presentation or a podcast maybe, or public discourse, or maybe a town hall meetings perhaps, presenting this is what we learned about convection. These are the data we gathered. We also framed some ethical guidelines to combat global warming or climate change. But our idea, the learning we got from convection informed us as well and helped us to frame this kind of guideline to combat global warming or climate change. So they can post on Facebook or in any whatever kind of documentation they will do, depending on how they decide, and they need to talk to the teacher as well. If the teacher will agree on exhibit or school publication or presentation, etc. So this model will, you know, shows what's the flow, but there is also an assessment dimension. And this is actually the table of everything I'm talking here. So the STEAM-X model has its NICNOC, I call it NICNOC learning cycle. That's why there is this NIK. And here is the student action for each phase, the teacher role, the AI role, I termed the outcome panalo because panalo is a Filipino term. In English, it is called winner. So if I say you are panalo, then that means you are a winner because panalo is winner. And each phase is being assessed as well. Assessment here, I'm not showing assessment here because it's still being developed. And besides, for now, I'm just presenting the model. Assessment will be probably soon. And assessment could be also defined by teacher themselves because they have this academic freedom. So in other words, what I'm just selling here is the model. And that's the flow. So what is the role of science here? Well, science, if you can say, the model is still really relative to scientific method that we used to know step by step. And then teacher here is a facilitator. There is a point where teacher will come in and to talk and refine the topic, which is in the knowledge clarification, the lecture part. AI, we notice that there are some areas here that AI are not present, for example, in the first phase, but AI is also staged or being embedded in a certain area, but with purpose. AI is not a default tool here, but staged or injected at some point because it requires AI for a better purpose. So that's how the model works. I know you got some questions later, but yeah, we can talk about those questions later on. So again, this model, I just developed this model from my PhD. This is not really my PhD. I just developed this one along the way. It only surfaced accidentally. So it's still being processed in terms of its intellectual property with the university while it is still being developed. Because of this accidental surfacing of this model, I also developed, established it's still in its preliminary stage, but already registered in New Zealand, a research lab focused on holistic science education, because anthroposophical science education also means holistic science education. That means it's not enough in anthroposophical lens, it's not enough to know the sciences and mathematics of the universe, like the mind, the nature of man or of the human being. It has its heart, the emotion, and the free will. And anthroposophy emphasizes that we have soul. So if we learn concepts in this physical realm, so it's cognitive that connects to the emotional, because we are human, to our soul, to our free will. Free will is the sound judgment, the execution or implementation side of our mind. So that's how anthroposophy explains. Yeah, I'm sure you got a lot of questions, but sure, I could probably entertain some of the questions now. Some of the parts here are still quite rude and developmental, but I would be happy to seek some very useful suggestion from Cash or Like and Kelly.
I had a question, but you kind of answered it already. But I kind of want to pose it anyway, just to get you to think about like
yeah.
the reasoning for the inclusion of AI, because in your description of the cycle, the model, I was thinking to myself initially, what is the affordance of using AI instead of just like, there's lots of visualizations about convection on the web and textbooks. The teacher can talk about it. Like, what does the AI actually Because every time we use AI, we're using a lot of
Mm.
resources. And I
Yeah.
think we want to give students the message both implicitly in how we use it and are asking them to use it, and explicitly that this is a really powerful tool that uses a lot of
Yeah.
resources. When is the right time to use it? Like, what is the thing that this super powerful tool can give me in this situation that I can't get from other kind of easily accessible resources?
Yeah. So because AI, well, in the past few years, I don't know what was AI, but because quite recently AI becomes a talk, it becomes word from every people. And then from my data, when I started to analyze my data, AI, even technology itself was not present in the teaching and learning in this particular Steiner school. This Steiner school, Waldorf school, embraces anthroposophy as a philosophy, and they do not use technology from
Yeah.
elementary, well, technology slash AI. They come together. um, Never being used in elementary because the elementary years must be focused on modeling, imitation, senses, the physical body like that. In the middle school AI, all technological tools are still not being used because anthroposophy explains that students are still not ready yet with the abstraction of concepts, still rely on hands-on experiential way. But in the upper school, technological tools and AI can be used. So questions like, when is the best time to use AI? So if in this case, for example, if I teach middle school, though I have no plan to use the whole of anthroposophy, so I just decided to come up with this kind of model because I tend to apply this in the public education. Recently, there are some issues in terms of using of cell phones and so on, and AI, for example, in the Philippines and even in New Zealand, becomes problematic. No specific ruling or guidance yet in terms of how exactly we use AI and when. So when to use AI is once the student or the learner already experience the concept. So AI in second phase is still limited, and I put here that only can be used, limited in the sense that can only be used when students already attempted their own structuring of or synthesizing based from the data they physically experientially gathered. So that's a time where AI can be used. But along the way, teacher must guide all the students. So yeah, I think I'm trying to respond to that question that AI, when is the best fit, is in the second phase. Only after students or anybody experientially understand the concept. That's the time, because the idea of anthroposophy or the idea of this model is it has to be first the human being to see
Yeah.
the reality first. That's
Yeah.
the idea first.
I'm fully
Yeah,
on board with that. I'm just wondering why use AI at all? Like seems like I
yeah,
could do the same model, which I'm 100% with you that the kids need to experientially, it's way more not just engaging, but informative for them. Like
yeah,
they're
yeah,
actually going to learn from that
yeah.
experience. I'm
Without using
100% on
AI
board
at
with you
all.
there. But why do they need the AI to help
Yeah,
them develop, like their understanding
yeah, exactly,
of,
Kelly.
yeah.
Yeah, That's very good because technically we can still do the flow, this model, without using AI.
Yeah.
Probably we can do simulation or textbooks, even textbooks. We can go back. Textbook in the absence, pretending AI will be absent. So the option here is they can resort to library or Google. Because the reason, because for example, if what, though this is just a model, for example, a nature-based kind of science instruction. So students will go out and map the nature or the environment and then collecting data and so on. So they are going to develop a specific concept based from what they observe in the environment. For many of the students, it's quite challenging to refine the concept or the objective of the lesson based on the gathered data. So they can use AI. But then again, it is true as well that not essentially, because I can still use textbook or Google or some sort of simulation. It is still possible. Yeah, for sure, Kelly. I agree with that. It's just that in this model, I decided to add AI because it becomes a trend in the past years. But pretending, what if we are going to delete this column, the AI thing? Is it still possible to run through the cycle or the model? Yes, it is still possible because there are still other options, not essentially AI, because there are still many ways to learn the concept or develop the concept experientially without using AI. I just added that idea because of the trend in the past years about AI. But for sure, we can delete AI in this model and not using AI at all. Instead, we can resort to the traditional, which is the textbook. Or if there is internet, we can still check internet. The purpose of AI or textbook or Google here or internet is just to refine their conceptual, their constructed concept. Because I understand there is this prepackaged standard definition from the book, but if I'm going to construct the concept based from the existing data, I can still express or define it, but still very crude. Students need to refine the concept that they constructed based from the data, empirical data they got. So AI could be a helpful tool to refine that. But in case we don't have AI, they can still use the existing resources like textbook and so on. Yeah.
If I could like really quick piggyback off of what Kelly said,
Mhm.
I was also thinking like I really like the model like in itself and the principle of it. Like for example, one of the most common models when we teach our STEM methods course here, we use like for example the 5E model or the 6E
Mm.
model.
Oh
And
yeah.
even in
Yeah.
that, you're doing
Mhm.
something similar where you're having the students engage and then they observe in the uh what explore phase and then
Mm.
they come construct their own explanations and then
Mm.
as a
Mm.
group you come to a consensus. So again you're trying to do like building the actual definitions
Mm.
through student understandings and observations. And from that perspective, like when I was thinking that even when we teach our pre-service teachers now, we after they do constructing explanations, we ask them to try to go through AI and then
Mm.
like check their what
Mm.
their own
Right. Right.
explanations and all that as
Yeah.
well.
Yeah.
And so like when I was thinking on those lines that, you know, now that AI is becoming so prevalent and we have to train our teachers to be
Mm.
prepared for it because some teachers are not experienced with it, but the students coming to class already
Mm.
use AI.
Mm. Right.
And
Right.
so I was thinking more on the lines of when you bring in the AI part, whether you can leverage that part, like Kelly was saying, to bring in the importance of how and when you need to use AI. For example, we
Mm,
emphasize all the time about how you need to use AI as a thinking partner and
mm,
not, you know,
right.
put
Yeah.
what, uh, put away your loads of thinking onto the AI. And
Mm,
that is what is happening a lot with a lot of students. Instead of like constructing their own explanations, they put it on AI, AI constructs an explanation, and then so they are not doing the hard work of thinking
Mm-hmm.
themselves.
mm,
So I
Yeah.
really like how you're including it, but I'm wondering if you could, push it in that direction where we are from, for example, middle school level and all, we are like training students on how to leverage this
mm,
technology in an
yeah.
effective way in order to improve their understanding and like see the same thing from different perspectives.
Yeah, yeah, I really agree with that, Kasia. Thank you very much for that. Yeah, actually, that's also my thought because how we can treat AI not as a threat, but a helper or to augment our thinking, like like a tool, like similar to calculator, like that. Because right now there's still some gray area on what exactly is the ethics of AI, especially in schools,
Mm-hmm.
in some universities. So like I myself, even me, as a PhD, I need to ensure as well that I need to be very careful how to position myself in utilizing AI in a way that it has its own purpose, not the author, something like that, but as a helper beside me. So yeah, that's a very good idea that I need to reflect on as well. Because if I'm the student, it will perhaps this model could help me to position how I could utilize ethically AI, um, still me as the author, and AI is the helper. Um, so I use the term staged or purposeful or purposive use of AI because AI should not be a default tool. Like automatically we use AI. There's a certain stage because based on the premise of ethical things and cognitive um, overloading and so on. So yeah, that's the plan. Sorry, I'm having a background. Something I need to say as well with this model is um, this model will help the student as well to like to teach them how to use AI and when to use AI. My experience with some high school students here in the Philippines, for example, even in New Zealand, they automatically go to AI. So like, yeah, that's a problem if I see it. Yeah. Okay, I think Kelly's gone now. Yeah. But anyway, I think it's already time. So, Gosh and like, thank you very much for that. Thank you for your time. And yeah, I appreciate.
Of
Oh,
Thank
course.
you.
Thank you
okay.
for
Yeah.
your presentation. It was great fun and best of luck for us.
Thank you
Yeah,
for the
yeah, yeah. Thank you as
presentation.
well. Do you still have questions? Sorry, we missed you. Or
Uh, the only question is that, what kind of AI you recommend to use? General AI like ChatGPT 5 or a well-designed agent? Uh,
Mhm.
in my university, we use Copilot. That is because of the security thing, the data thing. So the University of Auckland is recommending Copilot. And what's the other one? The notebook thing, I forgot the name. the one with the word notebook, LMS, or are you familiar with that? Like notebook.
I'm not sure.
Okay, but anyway, Copilot. We use Copilot. It is being recommended by the university. I don't know from Virginia Tech or from your university. Like I don't know what is being recommended there.
Okay, and another question is that how can we predict what AI will say, and can we control it and make it effective?
Though my field is not AI, and I'm in the science education,
Okay,
the
thank you.
question is how we can use AI effectively, if I understand it correctly.
To achieve our goal. Okay, never
Okay,
mind.
so so like I think if that's the question, to achieve our goal, we need to understand first what is the goal or the purpose of humanity, something like that. Because
I
AI could be a risk. Or Cash, maybe you can share something.
I think what he's correct me if I'm understood you wrong. Like, I think what he's talking about is like, how do you know that what your co-pilots or ChatGPT is telling is actually what you want the student to learn, or is it telling you the right thing?
Ah,
Like, how
yeah,
do you know that? And like,
exactly.
my personal view on this, like, I think like it's still developing the whole field. And
Mm,
like you were mentioning something about, more of a personalized, more agentic, almost AI. That once we have like, for example, here everyone has Chromebooks and Copilot is already talking about how you can have a local AI on your local computer, and that will like adapt based on how you learn, what your preferences are. So each person's AI will like give you responses based on how you like learning. That could be the future. It's not there yet, but yeah, I
mm.
think we all have to just keep thinking about it.
Yeah, uh, I
Yeah.
I got similar thought as well, Cash, because I remember from the university, they say that this everything about AI is still developing. Even in the publication side, there are still
Hmm.
some kind of unsureness area,
Yeah,
even in the publication. But I'm pretty sure, like you are coming from the artificial intelligence community, you are more expert on this. But normally, if I use Copilot or even ChatGPT, I don't really trust at all. I need to go back to the data and verify and everything because I'm not really sure. Is it true? Sometimes it's wrong. I experience that. So like, yeah, just verify. I think extra effort verifying stuff rather than relying on whatever it says. But overall, I find AI very helpful in order for me to think wider or better, or to
right.
express my thought because firstly I'm not an English native speaker, so it helps me to express
Absolutely.
myself. So but then I need to be very careful in every word I say, and I need to verify every word I say or whatever information I got from AI, etc.
Right.
So yeah, thank you, Cash, for that. Yeah. Mm.
Thank you. Thank you.
All right. Thank you very much. I don't know if you still have questions, but otherwise, again, I appreciate the time. Yeah.
Yes. Thank you
All
for
right.
having us. Best of
Yeah,
luck.
Cash. Yeah. Thank you. Thank you
See
very much.
you.
And good luck to us as well. Yeah. All
Thank
right.
you.
Take care.